Hello, my name is John Broadwell, and I'm an embedded systems consultant and medical device development consultant at my company, Broadwell Consulting Inc. Today we're going to take a look at a 6 degree of freedom robot arm that we're going to be controlling with the serial Wombat 18AB chip, along with a custom PCB that I developed, and perhaps we'll make available on Amazon. This is the first in a series of videos, and in this video we're going to focus just on the arm itself, show the arm, and how to assemble it. So this may be useful to anybody who bought this robot arm, not just people who want to control it with the serial Wombat chip. In the next video we'll take a look at the custom circuit that was developed to interface with those 6. Then we'll take a look at the C# app that I developed to control it and capture positions and replay them and whatnot. After that, we'll take a look at the serial Wombat chip's ability to filter outputs and provide output limits and a variety of things that are useful for robotics. Then we'll take a look at the ability of the serial Wombat chip to tie multiple pins together. So we'll make a 6-slider control that we can use to override the software, potentially to make it easier for us to capture points. After that, we may take a look at feedback. I haven't tried this yet, but I suspect that if we put a current sensor on the claw, we probably can use the serial Wombat chip's onboard PID control in order to detect and grip an object with a certain firmness. So that'll be an interesting one. I haven't worked that out yet, but I'm fairly excited about it. So let's take a look real quick at the robot arm that we'll be using for this series of videos. I got it off of Amazon. There's a link down below. It's not an affiliate link or anything like that, just the standard link. So I'm not getting paid. I just, tried it out. If you want to get the same thing and play with it, you're welcome, or do something else altogether. I don't care. But anyway, so it's a real simple kit, 6 servos and a whole bunch of hardware. And let's take a look real quick at a video that shows the thing assembled and talks a little bit about my thoughts on the kit and the assembly process. So here we can see the arm. Basically, it comes in a kit. You've got the 6 servos that go with it. One that does rotation, one at the shoulder, one at the elbow, one at the wrist, one that rotates the wrist, and one that controls the grabber. So the kit is kind of fiddly to put together, but not terrible. My advice would be totally ignore the instructions. The more you read them, the more confused you'll get. Look at the picture on the box and take a look at this video. I'll do a slow pan around the arm later so that you can see what's going on. Fundamentally, there's a couple of things you need to know. There are thin screws and there are thick screws. For the most part, the thin screws are used to attach metal pieces to other metal pieces. The thick screws go forward to a servo to attach the servos to the metal pieces. There are some aluminum round servo horns that are attached that attach the servo to the metal part. In my particular bag, I had a whole bunch more of these screws than I needed. There was actually 4 of these screws in each little bag that included one of these horns, and I think they also included duplicates of 24 additional screws that we didn't need, because I had a whole bunch of these things laying around and I really couldn't find anywhere to put them. So that's one side of the servo. You can see that the servos are used to mechanically hold the arm together. On the other side, there is a bearing, and that bearing, what you do there is just attach it. You can see the bolt in there that goes through the bearing that then goes up to the nut, and that, let me set my phone down here for a second. Then that provides the other half of the axle, or whatever you call it, that allows this to rotate. So, the arm is essentially a toy. This is not a serious robot arm. There's an enormous amount of play in everything. All of the parts that are made out of aluminum, I was surprised by that, even though it said it in somewhere in the description. I thought they'd be steel. I really wish they were, because I think putting a little tack weld on each of those things. I can't weld aluminum, I can only weld steel. Putting a little flux tack weld on each of these things might help a little bit with some of that play. Certainly make the thing last longer without maintenance of screwing everything together. So one thing to know is that the arm, the servos are not nearly strong enough to keep the arm up when they're not powered. So be careful with that. If you shut off the power when it's here, the thing will just go crashing down to the ground. You probably saw that in some of the Amazon reviews. One thing to note when you're putting it together, take a look at the range of motion of each of your servos and where the thing is going to go. So when you're putting it together, place the arm in its center position, then use one of the non-round, like typical servo horns, to manually position the servo into position before you put it together. If you don't do that, you'll put the whole thing together and find out that, you know, in some cases you're already at one limit of the range of motion. Like for instance, the wrist has a very narrow range of motion of, you know, maybe 120 degrees. If you put it together wrong, you'll be in a situation where the servo just can't turn. So be aware of that. These servos are adequate for this job. I would certainly recommend using a power supply that can give them the full 6 volts that you need in order to get as much torque as possible. For instance, even without a load, the servo over here cannot produce enough torque to manually lift the arm in that position. You have to be a little smarter about it than lift the arm into position, you know, bend the elbow, bend the wrist, and then do your lifting. So, you know, again, for 80 bucks, all servos included, the kit was good, you know, not a terrible value, and certainly I've had a lot of fun with it for the money. So I would recommend this kit. One other thing to note, the servo horns are attached with these little black screws. Those are included in the small bag that's included with each of the servos, so they're separate. So make sure you find these little black screws. They're very important in order to attach the horns to the servos. Don't use the thin screws that you're supposed to use to put all of the metal pieces together. So now I'll just do a quick pan. Oh, and the other thing, order yourself a set of servo extenders, because the servos that are at the end, particularly the gripper, the cords are not long enough to go all the way around down the arm. So unless you intend to mount your control board up here or something like that, if you're like me and you want your control board on the table, then you're going to need some servo extenders to be able to have enough cable to do that. And then I added my own cable ties. Those weren't attached to those weren't included with the kit. So let's do a quick pan around. Just we'll try to give everybody as much view of things as we possibly can. You can pause the video if you're trying to put together a particular step. Oh, the other thing, probably obvious here, but I screwed the base to this wooden board. The base is not sufficient to keep the robot arm from falling over. You'll have to secure it to something. So that's it. That's all it takes to put this kit together. If you take a look at these teasers up here for other videos, which will be available in the future. If you're watching this as this video comes out, they're not populated yet, but they will be. These are the follow-up videos that you might want to watch on the PCB design, the software design, things along those lines. And as always, you can get the Serial Wombat chip on Amazon, and there is a link to my website, serialwombat.com, that then will take you to my Amazon store from there. So that's all for this particular video. I hope you enjoyed it. I hope you found it useful, and have fun. Keep making stuff. If you're using the Serial Wombat chip for any kind of robotics or other projects with servos or similar, then please leave me leave me a comment down below. Tell me what you're working on. If you see areas where I could improve the firmware or the Arduino or C# libraries, then by all means, leave me comments there too. So any questions, comments, always welcome. If you like this video, like it, and recommend you subscribe if you're using the Serial Wombat chips, because I come out with new videos, and this is where I announce new firmware releases and new features. The Serial Wombat firmware is available on GitHub, and is constantly being updated. Subscribe below so that you can see the latest features and videos that come out as we fix bugs and add new features. The Serial Wombat open source project was created by Broadwell Consulting Incorporated. Broadwell Consulting Incorporated provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485, as well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting. Support requests for Serial Wombat should be sent to help@serialwombat.com and will be answered on an as-available basis. Also, feel free to leave your question in the comments below.